I think you'll begin to see evidence of children actually being more confident in their own thinking, children less expecting to be rescued, less inclination of students to say to teachers, can you show me how to do this? But rather, well, this is how I did it. Can I show you how I did it? Children will begin to look at other children's work to clarify their own thinking. And that's, you know, we're talking about a progression here, we're talking about a continuum, but in classes where children have been exposed to this, teachers are comfortable with this kind of teaching, the children will actually use the thinking that's in the room to not only navigate their own thinking, but move their own thinking forward and even make comparisons between thinking, and all of which just really deepens the overall thinking that's happening in the room.
I'm going to ask them to prove it.
Okay.
I'm going to ask them to say, I can't see your thinking, so how did you get there? Like, how did I want them to prove it however they want, whatever they choose to do, whether it be converting to decimals, whether it be pictorial, whatever it may be. I want them to prove their thinking to me, or to explain or show their thinking. I won't guide them to, like, I won't say, this is how you get the answer. It will always be a question to make them be reflective of what they're doing, which will make them think about their mathematics. So it will never be a write out, here's the steps and follow what I'm saying, or follow. The questions will always question their own thinking. So I know that when it comes to that point, I will look at the situation that they're in and question them, but not give them the answer.
Okay, now that you're all done, what I want you to do is I want you to prove this to somebody else. Okay? Just because you put it on a number line doesn't mean everybody's going to understand it. So I want you to think about what we did when we compared fractions at the beginning, if a half was greater than 3/4, and how people would prove the way they were thinking. You guys did it in a very different way. What did you use? You could use that. What else could you use? Whatever works for you to prove that this is the actual order that the fraction should go in.
Being able to ask questions was not something that was expected or necessarily tolerated when I was a student. This environment of co-teaching and teaching mathematics through problem solving definitely encourages students to ask questions. I mean, I think that's the basis of the lesson, is to question and to deepen understanding through questioning, and misconceptions could hopefully be clarified. If somebody has a question, it may clarify something for 10 other students, or even one other student is a valuable experience.
In the process of teaching through problem solving, we get children much better at that metacognitive piece, so they begin to be able to reflect on what do I know and what don't I understand. As they begin to do that, they will begin to say, wait a minute, I think I understand this part, but I don't understand this part. They become more comfortable with ambiguity.
You get to learn a lot more if we do a group and we discuss it or we talk about it. And I think at the beginning I used to think about my own ideas, never let anybody share their ideas with me, but now I get to allow the other ideas into my head.
I like his idea too.
Oh, do you?